Hello grade 12, please follow me from your book. This lesson is Newton's second law applied to connected objects, page 71. There are three examples in this lesson, three long examples. I need you all to study the examples before going to the exercise, and I will go direct to the exercise because they are the same like the examples. So I don't need to explain the examples because it is the same idea. Let me take number one. This is in page 79. A mass is A of 100 gram and B of 200 grams are attached to the ends of a light inextensible strings which hangs over a smooth pulley as shown in the diagram. Initially B is held at rest 2 meters above the ground and rests on the ground with a string. Then B is let go. Draw diagram for each mass showing the forces acting on it and the direction of the acceleration. Okay, this is the diagram. This is B and this is A. Look at your book and look at the answer here. This is expressing two forces, the tension force working upward and the weight, which is 0.2 times 10 the g, which is the gravity, because you know that the weight equals mg. This is m and this is g, so it is 2 newtons. And the other one, which is A, expressing two forces also. This force is the weight and the other force is the tension. And this is number I, which is draw diagram. Double I, write down the equation of motion of each mass. The equation of motion, I think this will go down and the other weight will go up because this is much heavier than this. This is 2 Newton and this is 1 Newton. So if I want to write the equation, it will be for A, T minus 1 equals MA. F equals MA. This F means that the resultant force equals MA. The resultant force is the difference between the tension force minus the weight, because the tension is higher than the weight, because the system will go up. And for B, the weight minus the tension equals MA, which is 0.2 times A. This is the equations. 3. Use your equation to find the tension in the string. If you solve these two equations simultaneously, you can get the T. Add the two equations. T will cancel the T. It will be 2 minus 1 equals, if you add this and this, it will be 0.3 A. So the acceleration will be 1 over 0.3, which is 3.3 or 10 over 3. This is the acceleration. And to get the time, number IV, find the time taken for B to hit the ground. To hit the ground, I will use this formula, S equals UT plus half AT squared. Since the weight of 0.2 kilogram is 2 meters above the ground, so it will cover a distance 2 meters until it hits the ground. So S equals 2. And the U, which is 0 because it starts from rest, so the velocity equals 0, times T plus half A, acceleration, which is this one, times T squared. And we can solve this equation to get the T. All this will be 0. And half times 10 times 3, it will be 5 over 3 T squared. And then flip this and take it to the other side. Then T squared equals 2 times 3 over 5, which is 6 over 5, get the square root. So it will be 1.1 seconds until it hits the ground. Number 2, The diagram shows a block of mass 5 kilogram laying on a smooth table. It is attached to two blocks of mass 2 and 3 kilograms. Okay, look at your book to understand. One is much heavier than the other. One is 3 kilograms and the other is 2 kilograms. So it will move to the right. All the system will move to the right. The diagram, the force diagram for each one is this. I think you know what to do in the. This is the weight and the tension, T1. We have here two tensions, T2 and T1, and they are different, and the weight and the reaction. And for this is the weight and this is T2. Number 2, double I, is write down the equation of motions. The equation of motion for this one, for example, it will be T1 minus 20 equals 2A, the mass times the acceleration. And for this one, it will be T2 minus T1 equals MA, which is 5 kilograms times acceleration. And this one, it will be 30 minus T2 because it will move down. 30 minus 2T equals 3A. This is the equation of motion. And then I need to get the the acceleration. The acceleration from number 3. If you add equation number 1 and 3, look at this. T1 minus T2 equals negative 20 plus 30, which is 10, equals 2A plus 3A, which is 5A. Look at this equation. It's coming from adding the equation 1 and 3. Then T1 minus T2 equals 5. This equation number 4. T1 minus T2 equals 10. Take the 10 to the other side, will be this. I will call it equation number 4. It is already here, equation number 4. And switch equation number 4 to be T2 minus T1 equals 10 minus 5A. Why? Because this part will equal this part. So by substitution here in equation number 2, so I can say that 5A is equal to 10 minus 5A. Take the 5A to the other side, will be 10A equals 10, so acceleration equals 1. This is how to get the acceleration. If you substitute the acceleration in equation 1, you will get T1, which is 22. By substitution in equation number 3, you will get T2, which is 27. The second part of this problem is saying that, which IV is saying that repeat part 1 and 2 including friction force on B and use your equations to find the friction force. If we make another force diagram for the metal block, you will include a friction force because there is a friction force now between the table and the block. I'll call it F. Since the T2 will drag the block to the right, the F will work against the T2, means it will work to the left. So the equation of motion now it will be T2 minus the T1 and F equals MA, which is 5 times acceleration. If you add this equation to the other two equations of the other two blocks, I will make this system. Look at the system. The only difference here is this one. But he mentioned that the acceleration is 0.5 in number IV, because he said that with acceleration 0.5. So I would change the acceleration to be 0.5, because since there is a friction force, so the movement will be much slower. So he said that the acceleration is 0.5. So I wrote 0.5 here. So this is the three equations. If you solve the three equations in the same way, you will get the friction force. Friction force will be 5 Newton. Okay. Number 3, problem number 3. In number 3, I will take I and double I only. Number 3, there are a car and a caravan. You can read the problem. And also, I need to write the equation of motion. I need to get show that the acceleration is 0.15. I need to get the acceleration. Here I will treat the whole system as one unit, means the caravan and the car is one unit. If the caravan and the car is one unit, so there is a driving force, which is 1270, against two resistance force, which is the 400 and 600, one for the car and one for the caravan, equals the total mass of the caravan and the car, which is 1800, times the acceleration of the whole system. From this equation, I can get the acceleration, which is 0.15. He said that make sure that the acceleration is 0.15, so it is 0.15. The second part of this problem, draw a diagram showing all the forces acting on the caravan along the line, and calculate the tension in the in the bar. So here I will take the caravan only. The caravan only expresses the force T minus 600 equals 1000, which is the weight of the caravan, times the acceleration, which is 0.15. From here I can get the tension, which is 750 Newton in the bar between the caravan and the car. I will take only I and double I in this problem. I want you to go to number 6 and do it. It will be your homework and your project. But before doing it, study example 4.5 because it's the same. Thank you.